When working with acid-base problems, it is very common to see things like pH, pOH, pKa, pKb, and pKw. So what does the P in front of all these terms that we have seen in the past videos mean? So whenever you see P, this simply means the negative log of whatever it is we are talking about. So if we take our Ka value and take the negative log of that Ka value, we are now left with pKa. So this is simply the negative log of our H3O plus concentration. This is the negative log of our OH minus concentration. This is the negative log for Ka. This is the negative log for Kb. This is the negative log of Kw, which at 25 degrees Celsius, remember, is 1 times 10 to the negative 14. So how do we use this to get an actual value? So it is worth going over our log rules, especially when we're working with acids and bases. So remember that log of 1 is equal to 0. And log is just using another scale to count. So instead of counting 1, 2, 3, 4, 5, we just count by factors of 10. So log of 10 is equal to 1. Log of 100 is equal to 2. And every time we add a 0, we just go up another number. So log of 1 times 10 to the 8th is going to be equal to 8. So if we have a Ka value of 1 times 10 to the negative 6, well, if we want to take the negative log of that, so we know the log of 1 times 10 to the positive 6 would be 6. But when we go the other way, log of 1 times 10 to the negative 6, this is going to be equal to negative 6. However, we are multiplying it by this negative out here, which makes this positive 6. So again, log of 1 times 10 to the negative 6 would be negative 6, but it's negative log, so this is equal to 6. So it is important to note, if we're dealing with, say, two acids, so we have acid 1 and acid 2. If the Ka for acid 1 is 1 times 10 to the negative 4, and this is Ka equals 1 times 10 to the negative 9, this acid, acid 1, has a larger Ka. 1 times 10 to the negative 4 is much bigger than 1 times 10 to the negative 9. Now, what does that mean about their pKa? Well, the pKa is just the negative log of 1 times 10 to the negative 4. So the pKa is simply 4. And the pKa for this is 9. So as we can see, a lower pKa is associated with a stronger acid. So this goes the same for all of these constants and for our pH and our pOH. The higher our concentration, or the higher our Ka, Kb, or Kw is, the lower that value will be when we put that P in front. It is a negative log scale. So the greater the value, when you take the negative log of it, it will actually decrease. So what we'll see when we run reactions and we're trying to solve for the pH, a very high H3O plus concentration will lead us to a very low pH. So whenever you see P, it just means negative log.